Hello everyone, uh, my name is Chinkla Karthik and my registration number is 19BCI0163. Today I am going to discuss about advanced data structure in B plus T. I have to guess B plus T. This was done under the Jasmine teacher's man. Yeah. Coming to the relevant features of B plus tree. B plus tree is an extension of binary tree which allows efficient insertion, deletion, and search operations. In binary tree, keys and records both can be stored in the internal as well as leaf nodes. Whereas in B plus tree, records of data can only be stored on the leaf nodes, while internal nodes can only store the key values. The leaf nodes of a B plus tree are linked together in the form of a singly linked list to make the search queries very more efficient. So in B plus tree, they are used to store the large amount of data which cannot be stored in the main memory due to the fact that the size of the main memory is always limited. The internal nodes of the B plus tree are stored in the main memory, whereas the leaf nodes are stored in the secondary memory. Quickly, let's see an example of how the B plus tree looks like and how it is going to be. Yeah, this is the B plus tree, which we can see here. So this is the parent node and it has two child nodes. They are called as the left subtree and the right subtree. In left subtree, it is further divided into different subchildren or subtrees. So the final subtrees are converted like singly linked list linked together. And the final B plus tree is looking like this. So now let's see how the insertion and deletion parts is going to be. Coming to the insertion, there are some few uh, field of rules we have to see here. Uh, Three main rules of insertion part are, the first one is that we have to insert a new node in the leaf node itself. We have to ensure that it is a leaf node. So, and if the leaf node does not have the required space, we have to split the node and copy the middle node to the next index node. And if the index node does not have required space, we have to split the node and copy the middle element to the next index page. So we will see an example here and we can get an idea how the insertion is going to be. Now insert the value 195 into the B plus T of order file shown in the following figure. So they have given a B plus T of order file and we have to insert the value 195. So 195 can be inserted in the right subtree of 120 here. So after the 120, right subtree of 120, the 195 will be added, means inserted after the 190, means after the child of 190. So after inserting at the desired position, the B plus tree looks like this. And here we can see that there are more, maximum number of elements here is more than 4. So it is going to be splitted up like, yeah, here. So the node contains greater than the maximum number of elements, that is 4. So we have to split it up and the medium node should be up posted up to the parent. So here the 190 is came under the parent and the both are split up. So now the new B plus tree is going to be like this. And here again we have more than number of 4 elements. So here we have to again split the 108 to parent node. So after splitting it up, there we can see that the new B plus tree is going to look like this. Now coming under the deletion part, deletion also contains 3 different rules. So the first rule is deleting the key and data from the leaves itself. So we have to delete the key only in the leaves itself. And if the leaf node contains less than minimum number of elements, we have to merge down the node with its sibling and delete the key in the between them. If the index node contains the less than minimum number of elements, we have to merge down the sibling and move down the key in the between them. So let us see an example. We have to delete the key 200 from the given B plus tree. So 200 is in the right subtree of 190. We have to delete here 200. After deleting the 200, we can find that 195 is only the lonely element here. So we can merge down it with the previous page, that is 129, 154. After merging down, the whole thing should be visible like this. After merging the two nodes by using 195, 190, 154, and 129, the B plus tree look as like this. So now the element 120 is the single element present in the monode, which is violating the B plus T properties. So therefore, we need to merge again using the 60, 78, 108, and 120. Yeah, and this is the basic methodology of how the deletion is going in B plus trees. So this is the part of coming to the relevant features and insertion and deletion. Now we will go to the advantages and drawbacks of how the B plus trees are. So coming to the advantages is means the records can be fetched in equal number of disk accesses, and the height of the tree remains balanced unless as compared to the B tree, means binary tree. And we can also access the data stored in B plus tree sequentially as well as directly. And keys are used for indexing and the faster search queries as the data is stored only on the leaf nodes. So these are the major advantages of a binary plus tree. Now going to the drawbacks, there are few drawbacks of how the B plus T is going to be. So now the first drawback is data can only be stored in the leaf nodes. That is a major drawback. And any search will ended up at only leaf node. Yeah, it is also a drawback. And the time complexity for every search results in O of H. Yeah, it is always depends upon the height of B plus tree, the time complexity is. So it ended up with the search results as the time complexity is in big O of H. And there is a waste of memory too, and it is an inefficient and also sometimes it is inefficient, not all that. And retrieval of records from large files or databases stored in external memory is time consuming. It is also a time consuming process to retrieve any data from big files or databases. So yeah, thank you for giving this opportunity, and I'm closing this section. Thank you.